A very good evening to all the lovely students. I hope all of you are doing fine. Welcome back to the YouTube channel of Chaitanya Gosala. My name is Anirudh Mehta, and as you can see here, I'll be teaching you chemistry over here. So I've been working here in Chaitanya Gosala for last 3 odd years. And today we'll be discussing about very important topic from the 11th standard, from the NEET point of view, which is going to be thermochemistry. Okay. So thermochemistry we'll be discussing today. It belongs to the chapter thermodynamics, which is your NCERT class 11th, chapter number 5. So before starting with the chapter, I would just tell you that I will be putting one more video on thermodynamics after this, so you can relate both the topics together, because thermochemistry is one independent topic. It does not depend much on the other first law and second law of thermodynamics. So we'll be doing it separately. Okay. So let us start. First, we'll start with some important concepts and the numericals, then we'll go for the numericals. First, we'll start with some of the concepts and the formulas which will be required today. So first of all, what is thermochemistry? Thermochemistry is nothing but it talks about the heat of a chemical reaction. So it talks about heat of any chemical reaction. Okay. All of you have seen many chemical reactions, like you know what is combustion, you know what is neutralization. For example, if I write a combustion means burning a fossil fuel with oxygen, right? Let's take a fossil fuel like methane, marsh gas. You know that when it burns with oxygen, it gives us CO2 and H2O. You can obviously balance this out by saying 2 oxygen here, 2 H2O here. Right now, the reaction that I have written is a chemical reaction. Okay, it is not a thermochemical reaction. Now, what do I mean by that? A thermochemical reaction means writing all the reactants and products, balancing them, and also showing the heat of reaction along with it. A reaction can be of 2 types, endothermic and exothermic. Endo means it requires energy to go forward, something like melting of ice. To melt the ice, you put it on the stove, switch on the burner, and then ice will melt. So it is an endothermic reaction. But this is the reaction which takes place in cars or in our LPG cylinder, right? In our LPG cylinder, the burning of fossil fuel will occur, or the LPG, the liquefied petroleum gas will occur, and it gives us a lot of heat in the form of the fire. So here actually some energy will be coming out. Let me write some random value. It comes X kilojoule amount of energy is getting released. So it becomes a exothermic reaction, means heat is released. So it is an exothermic reaction. Whenever you see a reaction where some amount of heat is released at the product side, it is exothermic reaction, and the enthalpy change of such reaction is written as minus of the value. So we'll write as minus X kilojoule per mole of burning of methane. Okay. So please remember, this negative represents evolution of heat. Negative represents evolution of heat. So this completely becomes a thermochemical equation where I can say that CH4 plus O2 gives CO2 plus H2O. Delta H of this reaction is minus X. Another example I'll show you for the endothermic. One of the endothermic reaction is decomposition of calcium carbonate. So I'll say CaCO3 solid takes some Y amount of heat, gives CaO solid plus CO2 gas. Most of the decompositions you must know are endothermic in nature. Most of them, not all of them. Most of the decomposition are endothermic, because to break the bonds, you have to supply the energy from outside. So in this case, Y kilojoule is amount of energy absorbed. It is getting absorbed. So I'll say delta H of this reaction is going to be plus Y kilojoule per mole. Plus represents absorption of energy. Absorption of heat. So I hope it is clear to all of you that what is an exothermic reaction and what is an endothermic reaction. You can also remember their diagram, the energy profile diagram. if it is an exothermic reaction and if it is an endothermic reaction. Energy profile diagram means we will represent energy or enthalpy versus time. The reaction is going on and how the enthalpy changes. For an exothermic reaction, heat comes out. That means reactant is unstable but product is stable. Because whenever the energy will be released, energy of the system will go down. And when the energy of system will go down, obviously system will become stable. So product is stable, less energy. This is the energy profile diagram. Okay. In the Arrhenius theory, you study that some activation energy is always required to do the reaction. So for exothermic, you will see that product will be below the reactant. So if this is reactant, this will be product. If I do opposite, that will become endothermic reaction, means reactant will gain some energy and become unstable product. Something like this. So this is our product. Okay, so remember these two diagrams as well. The delta H is nothing but the difference between the energies of reactant and product. This is delta H. Okay, so how do we write the value of delta H? It is always final energy minus initial energy, because in the thermodynamics chapter we will study that what are state function. Because delta H is a state function, it is always going to be final state minus initial state. Okay, final state minus initial state. So I can say delta H is nothing but enthalpy of product minus enthalpy of reactant. Because you can see here H of product is less in number. So I will do less minus more. I will get some negative value here. I will get a negative value here. So it tells us that it is exothermic reaction. It's like 5 minus 10. So negative 5. And for an endothermic reaction, again I will do delta H of the enthalpy of product minus reactant. Here we are doing high value minus low value. So delta H will be coming positive. Alright. Now we'll start with how to find these delta H. Okay. How to find these delta H. Every reaction you do not have to do in the laboratory to find the delta H. To find the delta H of a reaction, we can use some simple thermodynamical equations. Okay. So we'll start with types of enthalpies first. We will not be writing all the definitions over here. I have some definitions already written for you. If you want, you can just check them out after in the next slides. First of the most important enthalpy becomes enthalpy of formation. We will write as delta H naught formation. We call it as standard enthalpy of formation. Wherever you see that not written on the top, not represents standard condition. Standard condition is room temperature 298 Kelvin and 1 atm pressure. The room temperature condition. It's not STP. Okay, it is just standard condition, standard thermodynamics condition. So we'll talk about formation enthalpy. After formation enthalpy, we are going to talk about what is the meaning of combustion enthalpy, standard combustion enthalpy. Just now I showed you one reaction where methane was getting combusted. That was nothing but combustion enthalpy of methane. We'll see that by the definition what it means. After this, we are going to see very important enthalpy, that is going to be neutralization enthalpy. Neutralization enthalpy. For today's class, our aim is mostly to do the questions on the basis of formation, combustion and neutralization. There are n number of more enthalpies which are there. In every single chapter, you generally study that. For example, in the periodic table chapter, you have talked about already the ionization enthalpy, electron gain enthalpy. So depending on different reaction, you can have different enthalpies. Bond dissociation enthalpy, right? Hydration enthalpy, solution enthalpy, all those are also there. I have taken a few questions from each one of them and we will be solving them as well today. Starting with the formation enthalpy. What is formation enthalpy? Formation enthalpy means whenever you prepare 1 mole of any compound, 1 mole of any compound starting from its elements in their thermodynamically most stable state. So there are few things that you need to remember here. First of all, you need to make 1 mole of a compound. Okay, so if you want the definition, you can write it. Again, I am saying amount of energy released or absorbed, maybe exo, maybe endo, we don't know. There are many exothermic products, many endothermic products. Released or absorbed in formation of 1 mole of compound from its elements, present in their most stable thermodynamic state or most stable thermodynamic allotrope. See, when I talk about an element like hydrogen, carbon, oxygen, nitrogen, mercury, they can have different shapes and forms in nature. For example, if I talk about a carbon, pure carbon can be present as coal, it can be present as graphite, diamond, fullerene, etc. If I talk about oxygen atom, it may be present in the air as oxygen gas, ozone gas. Something like phosphorus may be present as red phosphorus, white phosphorus, black phosphorus. But out of all the forms, only one form can be most stable. Are you getting my point? Only one form can be most stable form. That is called as thermodynamically most stable form. Now, how do you know which is most stable? You'll have to remember it. Okay, because it is completely experimental. By looking at their energies, whichever is lowest energy form is called as most stable form. And these are the following forms which are most stable. For carbon, it is graphite. You have to learn this. Graphite is most stable form of carbon. Oxygen is O2 gas. For hydrogen, it is H2 gas. For nitrogen, it is N2 gas. Most of them you would have seen. Some exceptional ones are iodine as I2 solid, bromine as Br2 liquid. Okay, don't confuse between them. For other halogens, it will be gas only, F2 gas, Cl2 gas, but I2 solid is the most stable at room temperature and bromine liquid. Same way, you can have red phosphorus, P for red is not stable, white phosphorus. White is most stable, and S8 rhombic sulfur. There are other forms of sulfur as well, monoclinic sulfur and all, but the most stable is S8 rhombic sulfur, etc. So, this is what the formation enthalpy looks like. Let us see some examples. Okay. Now, whenever a reaction is written, you should know that which is a correct reaction for formation, which is not a correct reaction. Everybody, please be very careful while looking at it. I am looking at some formation enthalpies. Okay. Slowly we'll do so that next time when questions come, you don't do any mistake. All of you, please see here. If I want to prepare a simplest compound like HCl, what do I have to prepare? HCl. So HCl gas I am trying to prepare. How do I write its formation reaction? There is only one way to write the reaction. Follow the definition. 1 mole of HCl must be produced. 1 mole only, not 2 mole. You can't say H2 plus Cl to 2 HCl. That is not formation enthalpy. 1 mole HCl must be formed from its elements. Means it has to form from hydrogen gas and chlorine gas only. You cannot prepare HCl by other method. There are many more methods by which you can prepare HCl, obviously. Okay. You might have seen that chloride can react with HNO3 to give HCl. Okay. NaCl plus HNO3 can give HCl plus NaNO3. These reactions are not formation reaction. Must be from the element in the most stable state like these elements. So, I will take always 1 mole of HCl to do the formation reaction. For this, I will take H2 gas with Cl2 gas. Balance the reaction, never touch this stoichiometer. This must remain 1. So, I will take half mole of H2 with half mole of Cl2. Only this reaction is formation reaction of HCl. Okay. Whatever will be the enthalpy of this reaction will be called as formation enthalpy of HCl. I hope it makes sense. For this reaction, delta H of this reaction can be written as delta H formation reaction of HCl. Okay. One more I am writing, then rest you will write yourself. You please help me in writing. How do I write the formation of calcium carbonate solid? Think about it, all of you. Okay. Pause the video. Think about it. Write it. Okay. Right now we'll see. Calcium would come from calcium solid. It is the most stable state of calcium. Carbon, I told you, it has to be graphite. So, I will take carbon graphite. Don't write as carbon gas, it is graphite. G means graphite. plus I will take oxygen gas. For the formation, this must be 1 mole. So I'll balance it out. 1 calcium, 1 carbon, 3/2 O2. This reaction will be formation of CaCO3. I hope it is clear to everyone, right? So this is about it. Delta H reaction equal to delta H formation of CaCO3. Right? Now comes, what is the important formula that we have to remember to find delta H of any reaction from given values of delta H formations? Very, very important. See, this formula, even if you forget, first of all, we should not forget, because to do the question fast, this formula will be helpful. Even if you forget, I'll give you one more Mool Mantra, which is going to be Hess law, which will help you in every situation. Even if you don't remember any formula in thermochemistry, still you can do each question by Hess law, which is unitary method. So the important formula is, whenever you want to find delta H of a reaction, we know two things, that delta H is, first of all, it is an extensive property. Extensive means mole dependent. If you take 1 mole ammonia, if the delta H formation of 1 mole ammonia is 100, for 2 mole ammonia it will be 200, for 3 mole 300. So it is extensive, moles dependent. Also it is a state function. State function means always enthalpy change will be enthalpy of product minus enthalpy of reactant. So the formula is, to find delta H of any reaction, you can take enthalpies of product, formation enthalpies of product, and subtract it from formation enthalpies of reactants. The formula is not just this much. Before taking the formation enthalpies, you must multiply them with the particular stoichiometric coefficient as well. In the balanced reaction, and take the sum of total enthalpies of all the product minus sum of total enthalpies of all the reactants. This is the exact formula. Okay, so first learn this formula, that the enthalpy of a reaction from the given formation enthalpies will have this formula: summation of product enthalpies minus reactant enthalpies. One example I'll show you, then we'll move ahead to the next enthalpy. Okay, and also one more thing to learn here is, you tell me one thing. We said formation enthalpy means to prepare something from its stable state. Can you think of preparing oxygen gas from the stable state? You will say that, sir, oxygen itself is a stable state. So how do I prepare oxygen? So we say that there is no need to make the oxygen gas, because God has already created oxygen as most stable form, right? Even if you want to try to write the reaction, you will say, I will prepare 1 mole of O2 gas from O2 gas. You will say, sir, what nonsense is this reaction? It's actually not a reaction. No, that means your initial and final state is same. So delta H will be 0, because product and reactant are exactly the same. So remember it, that whenever you take formation enthalpies of these people, it is going to be taken as 0. They will not mention it, but you have to take them as 0. So enthalpy of formation of stable states is always 0. So sometimes what you will do, you will say, sir, data is insufficient. Data is not insufficient. Our knowledge might be insufficient. Okay. So keep your knowledge full, that formation enthalpies of these people will be taken as 0. Delta H formation is 0 for them. Then it is not 0 for what? It is not 0 for other things like ozone. For ozone is not the most stable state. No. You can make ozone. O2 gives O3. For that reaction, there will be some delta H. So ozone enthalpy of formation is non-zero. Water enthalpy of formation, non-zero. Okay? Because water is a compound. For every compound, you can prepare it H2 plus O2, H2. Like that. Alright. So this is the formula. Now I will show you one question from here, how we can solve. Okay, let us do one question from here. You write it down. I am giving you few values. They are saying delta H formation of ammonia is given to you as minus 45 kilojoule per mole. Delta H formation of nitric oxide NO is given to you as plus 70 kilojoule per mole. Delta H formation of H2O is given to you as minus 85 kilojoule per mole, and they are asking us to find the enthalpy of this given reaction. Given reaction is ammonia reacting with O2 to give NO plus H2O, and the reaction they have already given you the balanced reaction. Whenever you are doing the delta H question, always a balanced reaction will come to you, because if you change the balancing according to yourself, the delta H will change, because I told you delta H is a extensive property. If you change balancing, delta H is also going to change. So they have balanced the reaction something like this, saying that they are giving you 4 ammonia here, giving you 4 NO here, giving you 6 H2O here. Okay, 4 plus 6, 10. So 5 oxygen here. This is the balanced reaction they have given us. Quickly let us solve for it. Delta H reaction we have to find. I just told you the formula. It is going to be, so whenever you are solving such question, delta H naught reaction equal to, first bracket will contain formations of product minus second bracket formations of reactant. First we'll write the formula. There are 4 nitric oxide on the right hand side. So I will say 4 times, because 4 is the stoichiometric coefficient, never forget about it. 4 into formation of NO, plus there are 6 water, 6 into formation of water, minus left hand side, which is going to be 4 ammonias minus plus 5 oxygens. Okay, let us put the values and get the answer. So it is 4 times formation of NO. How much is it given? Plus 70. Plus 6 times formation of water. How much it is given? Minus 85. Minus 4 times ammonia formation, which is minus 45. Plus 5 times oxygen formation. You tell me, where is the value given for oxygen? It is given here. How much it is? 0. Because it is a stable state already. So 5 times 0. Okay, you can put in the values, solve for it. It is going to be 280 kilojoule from here, minus 85 into 6 times, which will be 510. If you check it, 510 minus minus plus 4 times 45, which is going to be 180. 180 plus 280, which is going to be 460, minus 510, which is going to be minus of 50 kilojoule per mole. Not per mole, you shouldn't write per mole, because the reaction is not for 1 mole of ammonia, it is for 4 moles of ammonia. So delta H reaction, no need to write per mole. But yes, delta H formation, whenever they are asking, that will always be in kilojoule per mole. So this is our reaction. I hope it is clear to everyone. Right. Then we move on to the second type of enthalpy, which is going to be combustion enthalpy. Now, what is the meaning of combustion? Combustion means burning with oxygen. So you take 1 mole of a fuel, mostly we'll take a fuel only, like CH4, ethane, benzene, cyclohexane. 1 mole only you must take and completely burn it with oxygen to give CO2 and H2, and a lot of heat will come out always. Always. Burning of fuel always gives you energy. You eat the food, food is a fuel for us. You eat the food, you are able to run. That means food gives you energy. Combustion of food is always going to be exothermic. You put fuel into your car and you can turn on the engine. Till the fuel is there, engine will stay turned on. That means your car will get energy only if petrol or diesel is there inside it. Okay. LPG cylinder, whenever you turn on, the fire will come out. That means it is also going to be exothermic. So first of all, combustion always exothermic. Amount of energy, write down all of you. Energy released, always energy released when 1 mole of a compound, we call it as fuel here. 1 mole of a fuel is completely oxidized with oxygen to produce carbon dioxide, water. If sulfur is there, it will give SO2. If phosphorus is there, it will give P4O10, etc. Whenever you do combustion, all carbon must convert to CO2. That is called as complete oxidation. If you get carbon monoxide, that is incomplete oxidation. That is not called as combustion. Okay. So all carbon must become CO2, not CO. Hydrogen must become H2O. Sulfur must become SO2, etc. Other things mostly will not come for our level. You remember, carbon should go to CO2, hydrogen should go to H2O. At 298 Kelvin. Whenever that not is written, I told you it is standard condition. So in all the definition, at 298 Kelvin, 1 atm, you should write. Now, let us see a reaction which can be called as combustion reaction. I gave you one example here if you see. In this, the first reaction that I have written, no, all of you see here, this first reaction that I have written, this is actually a combustion reaction of methane, because I wrote how many moles here? 1 mole here. So the name of this enthalpy, delta H naught reaction, can also be called as combustion reaction of what? Methane. Correct? And by the formula of delta H formation, what can I say? I can say that delta H of any reaction is delta H formation of product minus the delta H formation of reactant. So I can say this combustion is nothing but formation of these things minus formation of these things. Is it clear? What will you write it as? You tell me. You will write it as 2 times formation of H2O plus 1 time formation of CO2 minus 1 time formation of CH4, and this is 0 because oxygen ka formation was 0. So can I write it as one example saying that here I am writing delta H combustion of CH4 is nothing but on the right hand side after combustion we produced 1 CO2. So we'll say 1 time delta H formation CO2 plus 2 water we produced delta H formation 2 times H2O. On the left hand side we had 1 mole of methane and oxygen is 0, so I am not writing it here. Like this you can relate any enthalpy. Once you know what reaction is behind that enthalpy, you can relate any enthalpy with the formation enthalpy, any enthalpy. Next, if I say what is the hydration enthalpy of, or what is the hydrogenation enthalpy of benzene? Hydrogenation means what? To add hydrogens. So you take benzene, you add 3 moles of hydrogen, you make cyclohexane. Correct? That enthalpy will be called as hydrogenation enthalpy. How can I write it as in terms of formation? I can write like this. You can all see here another example. This is benzene, 1 mole of benzene. I added 3 moles of hydrogen here. It became cyclohexane. This particular reaction can be called as what? In other terms, you can call it as hydrogenation of benzene. So I can say delta H hydrogenation of benzene is what? It will be formation of product minus formation of reactant. What is a product? A product is 1 mole of cyclohexane, which is C6H12. So 1 time delta H formation of cyclohexane minus 1 time benzene, delta H formation of benzene. Write in the comment box why I have not written 3 hydrogens. Okay, I hope all of you know this, why I have not written. Please write it in the comment box if you are getting it. Okay, I'll be checking. So like this, you can compare many different enthalpies with the enthalpy of formation. If you know the basic definition, you can compare all these things together. Okay, that's about it. Next is enthalpy of neutralization. We'll be talking about it in next 5 to 10 minutes. First, we'll see some questions regarding them. Alright, this thing I've already told you, so no need to write it again. You can just see here. It is the heat absorbed or released when 1 mole of compound is formed or prepared from its constituent elements under their standard elemental forms. These are their standard elemental form: O2 gas, carbon graphite, Br2 liquid, rhombic sulfur, white phosphorus. Even if they mention S or acid, both is fine. P or P4, both are fine. No problem in any of them. Okay. So this is the one. You can remember this as well, that formation of H plus in aqueous state is also 0. Okay. Next one. Now let us see the question. All of you, please see here how to solve such question. Enthalpy of the reaction N2 plus 3H2 2NH3 is given minus 92. What is the enthalpy of formation of ammonia? Formation they are asking. So what is the reaction you see here? They have given N2 plus 3H2 giving you 2NH3. It's actually as all of you know, it's a reversible reaction, Haber's process. For this, delta H is given minus 92.4 kilojoule. And they're asking find the formation enthalpy of ammonia. Now I will tell you the other way to find. One way is obviously you will say, sir, for this delta H of this reaction is product minus reactant. You will say 2 times delta H of ammonia formation minus this and this, both are stable states. Can you see? Can I say both are stable state? So I'll take them as 0, 0. So delta H of this reaction is 2 times formation of ammonia minus 0 minus 0. So delta H is given minus 92.4 is 2 times formation enthalpy of ammonia. From here ammonia how much comes? Minus 46.2. Okay, no problem. It was a simple question. Do we have any other way to do it? Yes, other way is Hess law. Other way is Hess law. What does Hess law say? Carefully listen. They will give you some delta H values, formation, combustion, some other delta H, and they will ask you one of the delta H. One of the delta H they will ask, other 2, 3 delta H they might give you. What you do is, you write the reaction for every given delta H. You write the reaction of every given delta H. If they give you combustion delta H, you write the reaction combustion of methane, combustion of benzene, combustion of cyclohexane. Write their delta H. Write their reaction. For example, here they have given this reaction. So this reaction number 1 is given. So I wrote the reaction as it is. This is delta H1. What are they asking? They are asking formation enthalpy of ammonia. So asking what? Formation of ammonia. You write the reaction behind it. What is the reaction of formation of ammonia? Reaction is 1 mole ammonia we must make from the individual elements N2 and H2. We must balance it by keeping 1 ammonia here. So I will take half nitrogen, 3/2 hydrogen. This delta H is given. For reaction 1, delta H is given. For reaction 2, delta H I have to find. What do? You do some mathematical operation on the given reaction. Whatever mathematical operation you do, same mathematical operation will be done with delta H. Simple as that. If you double a reaction, double the delta H. If you half a reaction, half the delta H. If you add 2 reaction, add their delta H. If you minus 2 reaction, subtract their delta H. Simple as that. Now you tell me, how can I reach from here to here? Can you see, this reaction is nothing but double of the second reaction. Correct? So if I multiply this reaction with half, I reach to second reaction. Can I say half, 3/2 and 2/2 means this is going to be this reaction. So I can say equation 2, which is this, is nothing but half of equation 1. Whatever I have done with the equation, same thing I can do with the delta H. That means delta H of equation 2 will be half of delta H of equation 1. I'll just put the value. Delta H of equation 1 is given, minus 92. So half of minus 92.4, which is nothing but 46. I would suggest whichever question comes, you do it by Hess law. Forget about any formula, combustion formula, hydrogenation formula. No formula you have to learn. Just use your Hess law. I'll show you one more question here. Okay, let's see this one. All of you. I'll do it by Hess law. Okay, all of you can see here. They are saying heat of combustion of methane is given, graphite is given, hydrogen is given. Can I think of the three reaction, everybody? It's little bit of a time-taking process. It takes some time to understand it, but once you get it, you will never do a mistake. Here I'll give you one more formula as well. Okay, after just doing this, I'll give you one more formula. Okay, I'll give you formula first so that you can do the question a little faster. Then I'll show you Hess law. Enthalpy of combustion, I just told you what is the meaning of enthalpy of combustion. Now, write the trick formula. If delta H combustion of all the components of a reaction are given. If the delta H formation of all the components were given, we said reaction delta H is formation of product minus formation of reactant. But in case, if I say A plus B gives C plus D, A plus B gives C plus D, find the delta H of this reaction. If combustion of A is given, combustion of B is given, combustion of C is given, combustion of D is given. Formations are not given, combustion values are given. If the formations are given, you would say formation of C plus D minus formation of A plus B, product minus reactant. But if combustion are given, you do opposite. Combustions of reactant minus combustions of product. So there the delta H reaction becomes summation of delta H combustion of reactants minus summation of delta H combustion of products. Reactant minus product multiplied by their stoichiometric coefficient. Don't worry about where this formula is coming from, because just now I'll show you Hess law. It is actually coming from Hess law only. Every time when you use Hess law, this formula will automatically come. Don't have to learn this formula. If you can learn, it is good. It will make you do the question a little faster. Combustion reactant minus combustion product. Let us look at this particular question. Heat of combustion of methane, graphite, H2 are given. What is given? Heat of combustions are given. What is given? Heat of combustions are given. What are they asking? Find the heat of formation of methane. Find the heat of formation of methane. I told you, whenever you are trying to solve a thermochemistry question, you just do whatever delta H they have given, you write the reaction behind it. Combustion of methane, combustion of graphite, combustion of hydrogen means what? First reaction. Combustion of methane, 1 mole of methane getting burnt in the presence of oxygen. Okay. H2 must be formed in liquid state whenever you do combustion, because 25 degree pe water is liquid. Balance it according to 1 mole of methane, because combustion is always per mole. So I'll get 2 oxygen here, 2 H2 here. Okay. For this delta H is given. Let me call it as delta H1, which is minus 890. Okay. Kilojoule per mole. Second, they have given combustion of graphite. Take 1 mole of graphite. Graphite means carbon plus O2 gas, giving you CO2. It is already a balanced reaction, so I will not do any balancing. It is given minus 393.50. And for the third one is combustion of hydrogen gas. H2 plus O2, H2O. That is how hydrogen gas will combust. This is your atom bomb reaction. Or these days they say, no, hydrogen cars are coming out. This is the reaction. Hydrogen as a fuel. In the rockets also we use H2 plus O2, H2O liquid. We have to take it for 1 mole, so balance it properly. We need H2O means half oxygen only is required, half mole of O2 I will take. Delta H3 is given, how much? It is given minus 285.5. Can you write all these reactions when next time a question comes? If you say no, then I'm sorry, you can't solve the questions of thermochemistry. So you have to first know the definition, basic definitions of all the enthalpies to solve any question. Okay. So these are given. Find the formation of methane. Formation of methane. So I have to think of which reaction they are asking. How to do formation of methane? 1 mole of methane I have to form from graphite and hydrogen. So I'll take carbon, graphite plus 2 moles of hydrogen gas. This is what they are asking. Let me call it as delta H4, which is unknown. So I will try to reach to this reaction. You consider all reactions as just mathematical equations. X, Y, Z. You do know X plus Y equal to 3, 2X plus Y equal to 4. How do you find the value of X and Y? Same thing you can do here. I want to reach to this equation, everybody. Okay. Now, to reach here, what should I do? I need graphite on the left hand side. Which side? Left hand side. Where is our graphite? It is already on the left hand side. Whenever you want a reactant on the left hand side and it is already on the left hand side, you just add those equations. Okay. If you subtract, they will change their position. So when you subtract the equation, right goes to left, left goes to right. When you do add, they don't change their position. Okay. So carbon graphite is on the left. It was already on the left. I also want it on the left. How many are there? I want only 1 carbon. Here in the reaction also only 1 carbon is there. In the reaction also how many carbons are there? 1 carbon. I also want how many carbon? 1 carbon. So I don't have to do anything with the equation 2. I don't want to multiply it with anything. If I wanted 5, but there is 1, I would have multiplied the equation 2 with 5. Here because there is only 1 carbon, I also want 1. I'll keep equation 2 as it is. Equation 2 as it is with a plus I'll keep. Okay. Next, what do I need? I need 2 hydrogen gas. Where is hydrogen gas? It is here. How many are there? Only 1 hydrogen gas is present in the third equation. How many do you need? 2 I need. So I have to double the equation first of all. Whether I need it on left or right, I need it on left side. It is already on left. So I have to put a plus. Plus 2 times equation 2. 2 times equation 2. Then what do I need? I need a methane. On the right hand side I need. Where is methane? It is on the left hand side. But I want it on right hand side. So I have to subtract the equation 1. So our answer becomes equation 4 is nothing but 2 plus double of 3 minus 1. So can I say our delta H of fourth reaction will be delta H of second reaction plus double of delta H of third reaction minus delta H of first reaction. Now what did the formula become? Can you see? Everybody. Is it not becoming 1 time graphite ka combustion, 2 time hydrogen ka combustion minus 1 time methane ka combustion? What did I say? The formula will become combustions of reactant minus combustions of product. Automatically it became like that, no? Yes or no? H2 is nothing but graphite, which is here. 2 times H3, which is nothing but combustion of hydrogen, minus 1 time H1, which is combustion of methane. So you can directly remember this formula and solve the question. And I can say that it is going to be first bracket minus second bracket. First bracket will have combustions of reactant. 1 time combustion of graphite, which is minus 393. You guys tell me in the comment what would be the answer behind it. 2 times hydrogen ka enthalpy plus 2 times minus 285.5 minus 1 time methane combustion, which is minus 890. I want in the comment box, I need the answer for this, and also comment that it is crystal clear if it is clear. If it is not clear, I will tell you in the comment box only if any doubt is there. Okay. Please write crystal clear if it is clear to you how to do this question, and write the answer of this as well in the chat box. Okay. I hope you will be doing that. So these are the questions that we will discuss today. So today we have discussed two enthalpies. One is formation enthalpy, one is combustion enthalpy. These are the two most important enthalpies. Out of 100 times, 70 to 80 times question come from these two enthalpies only. Okay, so in the next video, I'll be continuing with the last enthalpy of the syllabus, which is going to be neutralization enthalpy, and on other enthalpies also we'll be solving a few questions. Okay, I hope this is clear to everybody. These questions I'll be telling you in the next classes. Okay, so today we'll keep it till here. Thank you very much. Make sure that you subscribe to the YouTube channel. I hope all of you will do very well in your NEET exams. All the best. Thank you.